Cool, we're live. So welcome everyone to the third episode of Let's Talk Manufacturing. Today I just wanted to go over a little bit of a workflow getting from Fusion 360 to CNC machining. I want to keep it really basic, and I really want this to be focused around answering everyone's questions. So feel free to stop me with what I'm doing and throw in a question, and I'll be more than happy to answer those questions at any point. The goal of today is to just go through, create some basic shapes in Fusion 360, and then go through CNCJS, zeroing out the machine, and then hopefully getting around to cutting and maybe doing some pocketing. Again, just keeping it really simple. The point here is to just show some different types of tool paths, make sure everyone understands how you post-process to get to the machine, and just sort of explain what a post-processor is and how these things work. Cool, can everyone hear me all right? Cool. So what I'll do to get started is I'll jump over and we'll jump into Fusion 360, and we'll just start by creating a project within Fusion, and then all I'm going to do is just create some basic shapes, and we'll go through camming those basic shapes using ChipX cutters, and then post-processing, and then going out to CNCJS, and then setting up CNCJS to be able to operate the machine. So I've been able to set up a machine here, as you can see. So we've got a little M1 sitting next to me here, and then I've got Fusion 360 open as well. So we'll see how we get on anyway. Cool. So now, what I'm going to do to start with is I've obviously opened up Fusion 360. So I'm sure most of you here have used Fusion 360 in the past, but if you haven't, when you first open Fusion 360, this is basically what you'll end up seeing, is a window like this. Fusion's broken up into lots of different modules. So at the moment you can see I'm in the model module, or the model space, working space, and then you've got patch, sheet metal, render, animation, simulation, cam, drawing. But today all we're going to be working on is model, and then going through to cam. Now, one of the great things about Fusion is that you have the ability to take one model all the way from design right through to rendering it, right through to actually manufacturing that model. Cool. So as you saw before, I've got a piece of white melamine sitting on the bed of the CNC. So all I'm going to do is draw that basically, and then once we've drawn that, I'm just going to insert some shapes within that, and then we'll go through and toolpath some of those shapes, and then we'll talk about some of the different kinds of toolpaths and how you can utilize those toolpaths. Cool, thanks for that, Casper. Good to know that there is a slight amount of echo. I'll try and bring the microphone a little bit closer so you don't hear that so much. I'm doing this in the workshop today because obviously I want to reduce the amount of dust in the office and that. So cool. So now I'm in Fusion 360. First thing I'm going to do is I'm going to create the piece of melamine that's on the bed. So I'm just going to model that. So first thing I'll do is just grab a rectangle. So at the top here you can see the basic drawing tool. So I've got line, I've got rectangle. If I select the drop down here, I've got a bunch of other things that I can do: circles, arcs, polygons, ellipses, slots, splines. The list really goes on with what you can sort of achieve. Offsets is something that I use a lot, but we probably won't go through all of those today. The main point of this is just to get the basics under everyone's belt. Cool. So when you first select whether you're going to select a line or whether you're going to select a rectangle, you then get this here. These are the three planes that you've got to work on. So you've either got a left-hand plane or a back plane or a floor plane. So the planes are all aligned as per the little triad up here, or the view cube up here. So I've got our top, I've got front, and I've got right. So I want to start by working on the bottom, obviously. So when I select that, now this here changes to top, and it's a bird's eye view of where I'm working. So at the moment, I've got a corner rectangle, but to be honest, for what I'm doing, it's probably going to be easier if I was to do a center rectangle. I prefer working with center rectangles. The biggest reason for that is it allows you to be able to drag out and keep everything central. Cool. Again, I'm not going to click anywhere, I'm just going to type in some measurements. So I know that the piece of board that I'm working on is about 500 wide by about 600 deep. So I'm actually going to make that a little bit smaller because I don't need to work all the way to the outsides of that piece of board. So to start with, all I'm going to do is I'm going to make it 300, and then I can hit tab and then do 300. So now I've got a piece of board that's 300 millimeters by 300 millimeters. Again, you don't have to do it this way. Another way that you can do this is if I again come back and select rectangle, let it snap to the center or snap to that point. So I'll select rectangle, drag out, press enter, then I can come and dimension that rectangle. So under the sketch tab there is dimension, but next to dimension it's also got a D. So that basically anything with a letter next to it, that's a shortcut key or a key that I can utilize on the keyboard to make something happen. So or call up that function. So all I'm going to do is select this outside line, drag it out, type in my dimension, again 300 millimeters. It's a little bit big, so I'll just scroll out there. The next one I'm going to do is select this bottom line, drag that out, and again just type 300 millimeters, just keeping this really simple. Now I know the material is about 16 millimeters thick, so again all I'll do is I'll just come up the top here. I can either click the extrude button, or again, see when I hover over extrude, it brings up an E. Now that E, what that basically means is, again, it's a shortcut key. So I can select E on the keyboard, I can then select the shape or the face that I wish to extrude, and then I can type in 16. And then that will extrude 16 millimeters. Now I can choose what I want, how I want to extrude, whether I want to start from the profile or whether I want to do an offset plane. Now offset planes are really cool because it allows me to offset my extrude from my initial sketch. That's really helpful when you're doing product design. You might want to do all of your sketches on a single plane and then you want to extrude them down to individual levels. But for this scenario, we'll just do profile plane. Now with direction, I've got some choices here as well. I can either do two-sided. Now two-sided, if I scroll around that and zoom up a little bit, if I go two-sided, it's now going to let me extrude on the opposite side of that plane as well, that same sketch plane as well. Or I can do symmetric, and all symmetric is going to do is if I was to extrude through the top and I was to extrude through the bottom, it would just double whatever I've done. I've got some options with that, so I can make the overall width. So if I was to type in 16 millimeters here, and I was to do whole length, that would change the whole length to 16 millimeters. If I was to just do one side here, that's basically going to double it, so we're ending up with 32 millimeters overall. So this is really good if you're trying to mirror something or mirror and extrude, and you don't want to think about what's on the other side of the plane, but that is still important to you. Now, for this scenario, again, I'm just going to come back to one-sided. One-sided is what I choose to use, and again, it comes down to personal preference, a lot of this stuff. Now, under operation, I've either got new body, or I've got cut, intersect, or new component, or join. Now, for most things that I always do, I like to select new component right from the get-go. It keeps things a lot cleaner. New components you can move around and you can join with other things, whereas bodies are a stationary item. You can move them to a point, but you can't drag them freely. You actually have to select and tell it you want to move that part. Cool. Now what I want to do is come up here and I want to rename this. So if I just rename this stock and then hit enter, now I've got my stock piece there. So again, I've got this little light bulb on the side here. I can actually come in, I can turn that stock piece off at any point. Now that's really helpful for models when you're starting to work with multiple components. Now there's another way to turn that off. If I've got lots of these rectangles, for instance, and I just wanted to work on one rectangle, I can actually right click on that rectangle and I can go isolate. And what isolate will do is it'll isolate that part, it'll turn all the light bulbs and everything else off, and it'll isolate that one single component. So that's really, again, really helpful for if you're creating multiple components within one single design. But again, for this scenario, we'll just keep it really simple, and we'll just create a single component. Yeah, there is some birds in here. Yeah, they're a bit of a pain, to be honest. Cool. So all I'm going to do from this point here is I'm just going to select again, I'm just going to select the top face, and then I'm going to extrude down into that top face. So first off, all I want to do is I just want to create a rectangle. The next shape that would probably be good to do is if I was to create a circle. Let's create a circle up here, something that we can do a ball with. So if I was to do a circle, again, when I select the center and I snap that center and I drag it out, it gives me a dimension. Now what I can do is I can just type what I want it to be. So I know that the cutter that I'm using is a 6mm cutter, so let's do a 10mm bore. Now, another cool feature with anything that we have here is we can pattern any of this stuff. But what I'll do is I'll dimension these first, and then I'll pattern them over to the other side, or maybe I'll mirror them over to the other side. So we'll see how we get on. So again, I can either come down and I can do sketch dimension, or I can just hit D on the keyboard. I'll dimension it from this outside first. I'll make that 50mm. And again, I'll make that 50mm. Now, I can come in here and I can zoom up on this rectangle. And again, I can dimension this as well. So again, I'll make that 50mm. And I'll make that 50. Cool. That makes sense. Next, I'll just dimension the circle from the outside again, keeping it really simple. Sorry if I'm a little bit slow today, guys. It is very, very hot in here, and I did open the door before, but there's a fair bit of wind coming in the back, so it was you could hear it through the microphone. So. Cool. I mean, what I'm trying to achieve here at the end of the day is I'm not making any particular thing. What I'm trying to do is I just want to show some basic features of Fusion 360, show some real basic CAM, and then show some real basic machining. The point is just to get people from absolutely bare bones basic, they've just opened Fusion 360, right through to being able to at least pocket and bore some holes. Just again, keeping it really simple, and in the future we'll get a little bit more in depth with some of the other cam features and some of the other drawing and sketch features and tools that you can utilize. Cool. Now, one of the things with CNC machining that is really hard is it's hard to go around square corners like this. So you can obviously use a smaller tool that's going to allow you to go around smaller corners, or the other trick is that you dogbone corners. Now, in some scenarios then that's fine, and it's not a bad thing to dogbone corners. If you're making a desk, for instance, and you're trying to make a little peg that goes inside that desk, it doesn't hurt to create a little dog bone, and that allows that square piece of timber or plywood or MDF to be able to slot inside a flat board. If you were to round those corners off, you'll have a little bit more trouble doing that, but most of the stuff is stuff that you'll pick up, and if you've got any woodworking experience, most of it comes as common sense as well. So for this, I will just add some dog bones to the corners. Again, it's a really simple thing to do. In the Fusion App Store, there's actually a little application for automatically creating dog bones, but again, it's not something I'll go through right now. So now, the next thing that I want to do is I just want to show everyone here how to do a rectangular pattern. Patterns are really helpful for if you're trying to create lots of holes and they need to be a particular distance apart. So what I'll do here is I'll just come and select the pattern, again under Sketch. I've got circular pattern or rectangular pattern. So for this scenario, I'm just going to select rectangular pattern. I'll select my sketch that I want to pattern out. I want to select my quantity, how many of those do I want to pattern, and then I can also type a distance as to how far apart I want these. Or I can just come and again just drag this, drag the arrow, and that'll drag out. Now that's saying that I've got 3 and I want them to be negative 55 millimeters apart. Well, I could have them 55 millimeters apart, but I want to get a little bit more precise than that. So again, let's go 60.5 because I want them to be 60.5 millimeters apart. That's not going to work because there's another point in there. So again, 60.5, and I want to have 4 bores because this is something has to slot into these bores. Just imagine. Next thing, I'll just push OK. Cool. Now we've got our 4 bores, we've got our rectangle. Now the next thing that I'm going to do is I just wanted to do a slot. Again, slots are something that's really handy. We use them all the time for creating cable relief, or if you're running cables through a hole. Again, it makes it really simple, and it's something that Fusion actually has those features built in. So now I'll go down to slot. Now we've got a few options with slot. I quite prefer using a center point slot. Again, I'll just snap to one of these points because again I can dimension that afterwards. I'll drag that out, and then I'll select my width. So I want my width for this slot to be about 20 millimeters. Now I can dimension the slot afterwards. That's why I wasn't too concerned at the time of dragging it out about where, the dimensions of that slot. Again, so I'll push dimension, and this is where you can go, okay, well I know that I've got 6 cables and each cable is 10 millimeters in thickness. So simple, I'll make that slot 60 millimeters wide, so from that center point I'll make it 30 millimeters, double that, that gives me my 60. Cool. Now again, I can come and drag this around because currently it's not constrained to anything. Now, one of the cool features with any drawing tool, generally Fusion 360 or Inventor or any of those, is they all have sketch constraints. So what I want to do is I want to constrain this center to the center of this here. So I'll come over to the side to my sketch palette. I'll go down to horizontal vertical constraints. I'll select that. Basically what I want to do is I want to select the center, and I want to select the center of this. Now I've got a constraint. Now what you'll notice is I can still move this side to side, but I can't move it up and down anymore. Again, because that's constrained along the horizontal plane at the moment. Now, if I had put something else in here, say I just grabbed a line, and I drew a line out, and we'll call this just a construction line for now. So what I'll do is I'll select this line, select X on the keyboard, and you see how that's just become a dotted line? That's a construction line. Now, construction lines you can't utilize for extruding, you can't utilize for anything. They're really designed around creating construction geometry. A lot of you have probably used Google SketchUp. Google SketchUp construction lines are used quite heavily, and that's the way that Google SketchUp teach you to do pretty much everything, is utilizing construction lines for lining things up. Cool. So what I want to do is I just want to add a dimension to that construction line again. Again, I just hit D on the keyboard, and then it automatically brought this up. So I just want to make that 100 millimeters. Now what I want to do is, again, I want to go back to my horizontal vertical constraint here, and I want to select this center point, or I could just come up and select the same constraint point that I did for the previous one as well when I was doing my horizontal constraint. Select that center point, select the outside point, and now you notice that the slot can't move anywhere. It's fully constrained. And you can see that by this little piece here. So this little rake looking thing here, now that's my constraint point. Now I can click on these and delete them. Again, when I click on it, I can highlight it and I can hit the delete key. And now all of a sudden I can drag that around. Cool, so what I'll do is I'll just go back to my horizontal vertical constraints. We'll add that constraint again. So that was just a little bit of a demonstration to show what you can do with constraints. Now there's lots of other options as well for constraining things. Parallel is something I use all the time. I'll just do a little demonstration of that. So if I was to do a line across here, and then I was to do, and then I wanted this line here to be parallel with this line here. Again, I could hit parallel, hit this line, and now the lines just become parallel. Now, when you're drawing, it is really, really easy to create lines or geometry that is not parallel or perpendicular to each other. It's something that I've done a lot, and it's something that I know a lot of other people have done a lot. It's a really easy mistake that's made. Now, one thing that I purposefully do, I'll just put this to the side for a minute, is when I am drawing, if I'm drawing a square for instance, I'll actually draw that square not square on purpose, so it's visually not square. Now, why I do that is it acts as a reminder to me that I need to constrain all of those lines. Now what I can do is I can go and select that I want this line and this line to be perpendicular from each other. Now I can select that I want this line and this line to be perpendicular from each other. Now I want this line and this line to be perpendicular. Now we're over constrained, so we can't do that one because this bottom one we had already constrained here. Now again, the rectangle here is on an angle, so again I can select my horizontal vertical constraint and I can make it constrained. Now I can still drag this around. Because again there's no dimensions on this. So again, this is where we can come back down and we can utilize our sketch dimensions and we can go around and dimension all of that. But just a little trick and something that I use quite often is when I'm doing things, when I'm in a rush, especially when I'm in a rush, is I will purposely draw that shape slightly out of kilter or on angles and add things that don't look quite right because it's a visual reminder that I need to constrain those things. There's nothing like going and getting to the cam point or going machining something and then you realize that one of those lines is slightly off on an angle, and it is a really easy thing to do. Cool. So what I'll do is just highlight all that, delete everything, and we'll get back to what we were just looking at. Cool, so what we've got here is we've got our rectangle, we've got our slot, we've got our 4 holes or 4 bores, and what I want to just do quickly is just delete and clean the sketch up a little bit. Don't need that. We'll keep this construction line in here again because this construction line is acting as a constraint for the slot up here. Now again, what I'm going to do is I'm going to come in as I'm just going to extrude everything down to the same depth. Cool. So again, we'll keep this really simple. I'm just going to go -3mm for everything. Yes, definitely. And make sure you like and subscribe what we're doing here, because the more people that come along and support what we're doing, the more videos that we'll make and the more confidence I'll gain. Yeah, I'm not used to making videos, and I'm used to just being able to have my own thoughts, and admittedly working in Fusion and trying to talk at the same time is not the easiest thing to do. I'm used to doing training, but most of the time when I'm doing training I've already set up slideshows, and everything's already sort of pre-prepped and pre-done. But with this I just wanted to keep it a little bit more live and a little bit more real, so you guys can jump in and ask questions as I'm going through this. Cool. So we've got our design here. We can see we've got our rectangle, we've got our 4 holes, and we've got our slot. Now, the next thing that I wanted to do is I just wanted to add some fillets to these corners here, because again, you can't go around a square corner with a bit. Now, Fusion's great, and most CAM programs are great. It will do its best to go around that, and it will basically, it won't delve into the corner and gouge it or anything like that. It'll go into the corner the best it can and just kind of round that off. Now, for what we're trying to achieve here, again, I did talk about the fact that we wanted to dogbone these. Now, that is an option, and what I might do is come in here and dogbone these now, just to show everyone how I go through dogboning something, just to keep it really, really simple for everyone. Cool. Again, what I'll do is I'll just come and grab a circle. I'll select this top plane again, because that's where I want to sketch. Cool. What I'll do is I'll just select the outside here. I know my bit now is 6mm. Now obviously when you're doing something like a dog bone, going into a 6mm hole is quite a hard thing to do. So ultimately what I want to try and achieve here is I want to just go a little bit larger than the tool diameter, just so the tool doesn't stall or get stuck within that tight radius. So what I'll do is I'll do 7mm. I generally like to keep about 0.5mm on either side of the cutter, especially when it's going around tight holes or tight bores like this. Cool. Now, the location of that doesn't make a lot of sense. There's no point coming up, and that's not going to work because the cutter's not going to fit through this point here. So what I'm going to do is I'm just, again, I can freely just drag and move the circle. I'm going to move the circle to the point where it's going to give me that nice sharp corner here, because what I care about at the end of the day is, imagine I've got something that I need to fit within those 4 points. So I don't really care about it going outside the boundary here. What I care most about is that the dimension from this point to this opposite point is going to come out precise, because I've got something that I want to slot in that. So for something like this, you don't need to throw dimensions in there or anything like that again, because I mean, to be honest, you could eyeball it, and for a lot of router work where you're just routering wood, and you're making a table or a desk, it's not a concern. Now, it's good practice to dimension everything and to constrain everything so nothing gets moved, but again, it's not something that's a big concern for this type of work. Cool. So I will dimension it, because I'm a sucker for dimensioning everything. Again, it's about playing with numbers to see what works here. I found that's what works best. So again, for this, I'm just going to do 2.5mm. And for this here, again, I'm just going to do 2.5. Now, my laptop seems to be a bit slow at the moment. That's right. Okay, so we'll see. you can see quite clearly see here that this is the corner of our rectangle there, and this is where the circle is. So we're actually inside the rectangle, which is not ideal. What we wanted to do is we wanted to be just outside it. So what I might do is if I just change that to 2.6, sorry, wrong way, 2.4, and again change this one to 2.4, and that is completely unnecessary, but I've got a problem with wanting to make everything symmetric. Cool. So you can clearly see there, that's our corner. We are well inside that, but again, there's nothing wrong with overshooting corners just a little bit, especially with woodworking, because wood has the tendency, depending on what kind of wood you're working with, to have a little bit of compression in it. And this is something we'll talk a little bit more about when we get into the cam side of things. Wood generally, when you're going around it, you can shock the wood or you can compress the wood inwards. So when you go and do your final measurement in most timbers, you'll find that the measurement can be out slightly. This is where something like plastics, harder plastics are quite often more accurate to cut, and the final dimension is going to be more accurate than if you're cutting softer woods. Softer woods, and I've noticed this with MDF and particle board, where you go and machine them, and you know the machine's accurate because you've just gone and cut a piece of plastic, and then you go and cut a piece of particle board or MDF, and all of a sudden it's a millimetre smaller all around the outside. And that could be something as simple as the fact that again, wood compresses, wood has quite a bit of give to it, and when you're going around and cutting that, you might not be able to see the wood physically compressing with your eye, but it is quite often. So again, now we know this is a full circle, it's a full square, sorry. So what we can do is we can then come back in and we can utilize our circular pattern. Now the problem is with a circular pattern is you need a center point for that circular pattern to work off. So what I'll do is I'll just come back and grab my line tool. Now what I can do is find the edge of this rectangle that I'm working on here. Cool. So now when I find that edge, I can drag up and down that edge, and then when I find the center point of that rectangle, it'll snap to that center. So again, then I'll drag that out. Now what I can do is I can actually come along the bottom here to find the center of it. So again, there you go, it's given me a little triangle, and then I can drag up and it's given me the exact location. Cool. 25 millimeters, that's what it is, because it's a 50 millimeter rectangle. Again, now because I know the dimensions of this rectangle, I'll just come in and dimension that. But again, it's pre-constrained because I've got the little triangle in there, and the triangle is basically already saying that that's center point, that's the center point. So I could use this midpoint constraint here to do exactly the same thing. Cool. So now what I can do is I can turn this into a construction line, because again, I don't care about it. So again, just clicking on it and pushing X on the keyboard will turn that into a construction line. If I do want to use that line for any reason, I can just click on it again and push X on the keyboard, and that'll bring it back to being a normal line. I have a feeling that it's the same command within SketchUp. I might be wrong about that. I haven't used SketchUp for a very long time. But yeah. Now the next thing that I'll do is I'll come in and I'll just do a circular pattern. I'll select this here, I'll select my center point. My center point is this point here. Now obviously that's not going to work because there's 4 sides to a square or a rectangle, so I'm going to want one more. Now if I scroll down here, under quantity, I can either go down to 2, 3, 4, 5, 6, but again we'll just go back to 4 because 4 is all we need. Now if I go and select the OK button here, we've got all 4 of the circles that we need. Now, what I'll do is I'll just come and extrude all of this leftover material here. So I'll just hit the extrude button, select that, drag over, select that, Now we already know that we're negative 3 millimeters, so what I'll do is I'll just go -3 again, and then that'll extrude down to the floor, and I'll push OK. Cool. So there we go. We've now got our rectangle, and we have dog bone corners. Now, can't see this very well at the moment, so what I might do is I will just change the appearance if it displays. Again, I'll show you guys how I just did that for reference. So what you can do is right-click anywhere on the in your working environment, and you can click Appearance. Now in Appearance you can go down to Paint. You've got Glossy, Metallic, Metal Flake. You've got lots of different choices. You don't have to use Paint. You could use Metal, but again, I'll just come and select Glossy. I'll come and select Red, and I'll drag. No, I don't want to paint the whole thing. I just want to paint that single face so we can see that. Cool, there we go. That'll make things a little bit easier. Now we can see our square there. That's got those. Now again, I'm not a big fan of this sort of stuff here. The cutter's then got to turn a sharp corner. So what I like to do with things like that is just add a little fillet to that. So again, we can, under the Modify tab up here, we can select Fillet. Or, as you guys would have seen before there, under the Modify tab, under Fillet, there's actually an F. So again, I can just come back on my keyboard, select F, and select these corners. Just going around and selecting all the corners. You don't need to hold shift down or anything like that while you're doing that. All those corners will select if you just select them all one at a time. Now all I'm going to do is do a 1mm fillet, and that just prevents the cutter from having to take a sharp corner around that there. So there we go. We've got our slot, we've got our bores, and we've got our square. So now what we'll do here is I'll just save this design quickly, and then we'll take that and we'll go and cam that. So all I'll do to do that is I'll just come up the top here, hit the save button. Most of you guys will already know how to do that. Just save this in our in-house projects folder. Let's call it test 1. Cool. So now what I'm going to do is I'm going to take this into cam. Cool. Now, does anyone have any questions before I move on to cam with the design and what is there any tools anyone would like to know how to use? Just basic things for the moment. Cool. Make sure that if you guys do have any questions, you jump in and ask those, and just stop me. Cool, so the first thing that I want to do is I want to do a setup. I need to tell the machine which is up, which is down, which is left and which is right. That's fundamental to CNC machining. So again, I'll just come and select the setup folder here, select my orientation. Again, the way that I do this generally is I select my Z-axis plane and then I select my X-axis plane. You can also select Z-axis and Y-axis, and then you can also utilize and select your X and Y axes. But again, I'll just come in here, select the top face because the top face is what my Z-axis is. That's what I'm going to work from. My X-axis is actually already in the right orientation, but I am going to come and select it anyway, and that means it's locked in. So again, it's selected the edge. Stock box point, where do I want to zero the machine out? For something like this, I actually just want to zero it out in the corner there. So I'll select stock point, and I'll come and select this point. But there are some really cool features with this, such as I can come back in and I can go selected point, and I could select that point there. Now, for instance, if there was an existing feature and I was bringing in another part and I wanted to just do some engraving, or I wanted to cut a hole in a panel or something like that, or into a wooden box or a coffee table, again, and there was a bore there and I wanted to utilize that bore for my 0 point, I could just go and select that bore. Cool, but for this scenario, there is, as you can see, on the machine itself, there isn't any existing holes, so I'll just select the corner of the material. Cool. Now, under the stock tab here, this is where I can go, well, is my stock bigger than the size that I'm working with? And I do know that it is. So what I might go and do is I'll just go and grab a tape measure and I'll go and measure that stock. And then I'll type in the exact dimensions here. So currently the width is 300 millimeters, the depth is 300, and the height, the z-axis height is 20. Now I know the z-axis height is not 20, it's 16. But it's rounding it off to the nearest whole number. So I'll just go and grab a tape measure. Cool. So all I'm going to do is just come in here, measure the stock. It's 530 millimeters by 605. Now I can jump straight back into Fusion again, and I can do 530 by 605. Now, that's obviously not going to work, because again, our 0 point's over here, but again, I can come back now and I can actually shift that. I'll go to stopbox point. Now it's already jumped to that outside point. So I'll come back in here again and yeah, you are correct, Casper. You don't need to always define the stock. One thing that you will find though is the stock will always add a millimeter to the outside of what you're working on. The Fusion 360 will automatically add a millimeter to the outside of what you're working on. Again, that's just a matter of going in there, correcting that, and then going in there and selecting what exactly you want. I mean, machines in general and CAM in general, it does what you tell it to do. So it's all about setting it up for what you want. And unfortunately, with a lot of CAM programs, there's no way to automate that or to make that really easy. There are some programs out there that automate all of the setup for you, so you don't have to go through it. But again, most of those programs are either really expensive or they're really dumb in how they operate, and they don't allow you that many parameters. Cool. So what I'm going to do now, we've got our stock, we've got our material in the centre here. I'm just going to come in here and press OK. Now to start with, what I might do is we might just go and do some bores, and I'll just go and post-process those bores, and then we'll see how we're getting on for time. Again, I don't want these videos to be too long, so the biggest thing here is for everyone to understand how to get a part from design right through to actually being able to run it on the machine. And then in the future I'll just get a little bit more in depth with perhaps CAM or drawing or actually posting and getting to the machine itself. So this is just a general overview. Cool, so what I'll do here to start with is, like I said, I want to do some bores. So to start with here, I'm going to come in and I'm just going to select the bore. Now, On CNC machines, I generally, it's generally recommended that you do bores instead of drilling. Drilling's really good if you're trying to do something really fast, but again, end mills are not designed to drill. It's really bad practice to do that, and they will wander. Your best bet, if you do want to drill lots of holes, is actually just to put a drill in the machine. If you are trying to cut some round holes, the best thing to do is bore, and what that'll do is just interpolate around the outside of that hole there. So again, I'll just come in, select my tool. Now I've already got my ChipX library in here, and I know that the cutter that is in the machine down there, that cutter is a 6mm single flute down. So what I'll do is I'll just come in here, drag this out so I can see what it is. 6mm single flute down, there we go. 6mm, it's got a 1/4 inch shank, and it's a down cut. So again, I'll just come in here, we'll push OK. Now we'll come in and we'll select our geometry. Now the geometry is obviously these holes here. Now, for something like this, there's quite often scenarios where you want to get a really accurate hole, and when you first come in and take a really big bore and you take a big chunk of material out in one go, you're not going to get the most accurate bore. So one thing that's really good sometimes to do is actually come in and do a clean-up pass, or even just come in and do a spring pass, they call it, where you actually just, you don't add a negative offset or anything like that, you actually just come in, cut and run that same tool path twice. And all that's doing is, again, if there has been any compression in the material, if there has been any flex in the tool, it's just going to allow you to come in and clean that hole up a little bit more. Cool. Now there's nothing in here that you're really going to need to change. There is the option to do finishing passes. Now the finishing pass does exactly what I basically said, except it bores, so it does a slightly smaller bore, and then it sets an offset, a step over here, and that step over basically it steps out by that and then does another lick around the outside. Now I'm not an overly big fan of doing that, especially not in timber. If we were cutting aluminium or something that doesn't have quite as much give to it, I would say that that's a good way to do things, but I've found quite often in timber it doesn't, there's no advantage to doing that. And it doesn't remove that spring within the material itself. So quite often what I do is actually just repeat that last finishing pass. So you've got this option here, repeat finishing pass, and that's all I've done. So when it gets to the bottom of the hole, all it's going to do is go around one more time, and that's going to allow it to clean that out. You do have the option to leave stock, and I've spoken to some of you in the past about leaving stock and how this can allow you to have a more accurate cut, or perhaps you can come in with a different type of cutter altogether and you can actually go in at a slower speed and go and clean everything up. Now quite often for contouring, you do this when you're contouring, you might want to go and machine something first, and then you might want to give a really accurate cut. So you'll leave some stock and then you'll come back in again with a cutter, and you might halve the speed, the feed rate and the RPM, and you'll go around and you'll just clean the outside of that hole up. Again, that removes the chance of the bit flexing itself, and it removes the chance of a little bit of material compression. You are correct, Daniel, you can import stock models, so you can model that. I could have modelled that whole stock. I just didn't have a tape measure right at that moment when I was drawing this up. So yeah, that's something that I actually do quite often for when I'm running the hearth. I'll model the stock in there, and that allows me to make sure that I'm not entering the cutter right in the middle or in an odd spot for whatever reason. And then you can place your model within that stock. Cool. Now what I'll do is I'll just turn off stock to leave, because again I don't need to leave stock right now for what I'm doing. This is where I can type the pitch. Now you can easily see here the pitch of the bore here. If I was to type 2mm, that pitch gets a little bit steeper. Now for timber, again, 2mm is fine. We could even go 3mm. But I mean, with a lot of this stuff, the more aggressive you get, the more especially in a lot of woods and things like that, you'll find that's when you'll get more chipping. If you're using especially when you're using something like a single flute cutter, you really want to be able to clean those edges up nicely. So I'll just go back to doing a 2mm pitch. Now, one of the problems here is we're obviously going to be zeroing out our material all the way over here, and we'll be zeroing the z-axis out all the way over here. So the z depth may be different at this point to this point because material bows. There's always bows within material. So quite often you'll zero it out at one point, you'll zero it out over here, and by the time you get over to this point, the material is slightly higher or it's slightly lower. So you could end up with the tool actually starting the bore once it's already entered the material, and that again can cause damage to the machine, it can cause damage to the tool itself, and it just causes an inaccurate cut. So quite often what I do is I go back to my heights tab when I'm working in material, and I'll just change my top height, and I might add two or say 3mm to that top height. Now, if I zoom back up again, you'll see what's happened here basically is that has added. There we go. So that's basically added another 3mm to that entry point. Again, that just acts as a little bit of a safety height for the point when that bore starts, and it allows you to, it means that the whole setup is a little bit more forgiving. So especially if you're doing a job that's repetitive and you're going to come in again and again and machine that, and you don't want to have to check and make sure every piece of material is perfectly flat, again, this is a really good safety mechanism to allow and make sure that you don't start the bore already in the material. Cool. So again, what I'll do is I'll just come back and I'll just check my tool. Our RPM, no, we want to bring our RPM up to about 15,000. Our cutting feed rate, we'll do that about 2,000 millimeters a minute. Our lead-in feed rate, 1200 is usually pretty good. 12 to 1500 for lead-in is usually pretty good. Again, we covered feeds and speeds a little bit more last week with Gavin Bath, so if you want to look at hear a little bit more about these numbers and what they relate to, I'd highly recommend going back and watching that video as well. So these numbers I'm just typing in are just from personal experience. This is what I have found works. Wood routers are a lot more forgiving. That's partly why I'm not going in and utilising a feeds and speeds calculator. That's really not what I'm hoping to achieve here today. Again, what I'm really hoping to achieve is just basic workflow for everyone. So our ramp feed rate, we'll just put our ramp feed rate again at 1500, that's fine. Plunging, we're not doing any plunging, so that'll be fine. Again, I'll just come in here and push OK. Now, what we want to do is we just want to simulate that. So again, I'll just come in here, hit the simulate tab up the top, turn our stock on, and we'll push OK. We'll simulate what's going to happen. There we go. So it's coming in, you can see it's going in twice and it's doing that clean up pass. Just as we talked about before. Cool, that should be better, Casper. You're correct, there was a second microphone turned on, so I've just turned that off. I didn't actually realise that I had a second mic at the time, so cheers for letting me know. Cool. Now, what I'll do is we'll just come in and we'll post-process this, we'll go through zeroing out the machine, and then we'll go and just run this little program. Cool, so the first thing I'm just going to do is I'm just going to right-click on my setup file, and I'm just going to select post-process. And Fusion is being silly. There we go. Okay, it's loaded all my posts. Now, it's already got the post processor in here, but again, you can just scan down. Now, the post processor I'm using today is just the standard one that comes with Fusion. There's obviously the one that the post processor that CAD Pro have on their website. I'd highly recommend downloading that. That one has just been a little bit more tested with our machines, but again, I don't actually have that post on my laptop, so I'll just... The existing smoothie post does work. There's a couple of known issues with drilling and things like that, but again, it does work for general purpose work. So I'll just come in here and use this post processor. I'll select my maximum high feed rate. So my maximum high feed rate for this machine, I'll just make it 4,000 millimeters a minute. There's nothing else that really needs to be changed in here. And again, since this is a new copy of Fusion that's installed on my computer, once you've type this in once, you'll never have to do that again. Again, you can rename your program for our machines, you can call it anything. So I'm just going to go bore test 1. Cool. So what I'll come in here now and do is I'll just go and press post. I'll save that on my desktop. Again, sorry guys about being a little bit slower today. It is very, very hot in here, and there is no air conditioning at all. So it just means I have to think a little bit harder to achieve things. That's okay. So now we've got CNCJS open. Now, what I might just quickly do is I'll just demonstrate with CNCJS how to utilize the basic interface. Again, I won't go too in depth. Look out in the new year for some little focus videos that we're going to be doing around Fusion 360 and CNCJS, so everyone can get a little bit more of a feel about how to use these products. So what I'm going to do first off here is we've got our homing button. You'll notice in the new version of CNCJS, before the machine will actually operate, you've either got to home the machine or you've got to come over here into the console and press enter. Now, all that is it's a lock mechanism. It's basically forcing you to do something before you start jogging the machine. So, again, I'll just come in here. There we go. Cool. So now what I'm just going to do is I'm going to jog the machine and we'll go through zeroing it out. So again, up here we've got a little keyboard button. So if I highlight that keyboard button, I can then jog the machine directly using my arrow keys. And if I hover over it, you'll see what it actually states here. And it says that if I hit my X plus, X minus, I can use my arrow keys, the left and right arrow keys to control those, and then the up and down arrow keys obviously to control the y-axis up and down, and then I can use page up and page down to be able to control the z-axis up and down, movement up and down. Now, one thing before you start jogging the machine that you need to be really careful about within CNCJS is you need to make sure that your jog increments are down to 1 millimeters or lower. Now, the problem is it's based on keyboard refresh rate. So, if I was to go and select 10 millimeters and I was to hold that down and my keyboard refresh rate is fast enough, you'll end up crashing the machine into the front. Now, you won't do a lot of damage with these machines. Again, step motors are very dumb in how they operate. There's no gears or anything like that. You're not cracking anything. The worst that's going to happen is the machine's going to lose position. But again, if you just home the machine, that's going to correct that position. Any steps that have been lost, that'll just correct those steps that have been lost, and you'll see that within CNCJS. So what I'll do now is I'll just got so many things running here on my computer. My computer's running a little bit laggy today. That's all right. So Cool, so we'll just keep jogging that forward a little bit more. Cool. What I'll do is I'll just jog the x-axis over a little bit. Again, just x plus to jog it over to the right there. And then we'll do z down. You are correct, I'm using OBS. OBS works alright, but I've noticed that it does put a lot of strain on the computer, and when I wasn't running OBS, I had no problems jogging the machine around, but now it seems to be a little bit, seems to want to lag a little bit more now. I think in the future I might set up a second computer for running OBS. Cool. So again, with what I'm doing here, I don't need to be too precise. All I want to do is I want to make sure that that tool there is basically just sitting on the corner. So again, I'll just come back into CNCJS. Most of you guys have seen CNCJS and how that works. I can basically come in here and I can select the zero out, and I'll zero out my X, I'll zero out my Y axis, and then I'll zero out my Z axis. Now from this point, all I'm going to do is I want to jog my Z axis up above the highest work holding that is on the bed. So my highest work holding are my clamps that are around the outside. You guys can all see those, hopefully. So the reason that I want to do that is I just want to make sure that when I do push play on that program, that it doesn't drag and hit any of those clamps. The other thing you can do is home the machine. That's quite a common way to do that. And on the Haas and things like that, I always home the machine once I've zeroed it out before I run the program. And that, again, it's just a safety feature and a safety mechanism to make sure that you're not going to break any tools and nothing's going to hit anything that's important. So what I'll do is I'll just come in here, upload my G-code now that I've zeroed everything out. I did save that file on my desktop there, so I'll just come to my desktop, bore test number 1, wait for that to load, we'll scroll out a little bit, there we go, there's our 4 bores. So this is the point where the router is currently. You can see on the screen there, there's right in the center there. Now what it's going to do is it's going to travel from that point on a diagonal all the way back, and it's going to do these bores in order from left to right. So that's okay, we'll go through that. Now the first thing, like I said, that I want to do is I just want to raise that router up. Now for something as simple as that, I can come back here, scroll down and go 20 millimeters, and I'll hit that a couple of times, and that'll get the router up nice and high above any work holding that I've got. But again, good practice is I always like to home the machine before I run it. It does take a little bit longer to do that, but you only need to do it really the first time you run the program. Once you've run that program once and you know everything is safe and you know how the program works, then again you come back and do it again. And that's the same with feeds and speeds. Generally, if you're running the program lots of times, you always want to run that program a little bit slower, and then once you're satisfied and happy with that, you come in and go back into Fusion 360 and speed everything up again. Just again, really good practice, and it's not overly hard to do that. It does mean that it makes the process a little bit slower, but again, it just covers everything, because the last thing you want to do is break tools. Cool. So what I'll come in here, it'll probably be a little bit loud. Let's turn my router down a little bit. Cool. What I want to do now is just put my safety glasses on, of course, and just come in here and push the play button. Now you'll see there it's going in that second time, and it's just doing that final clean-up pass as we talked about. That's with a 2mm pitch ramp, and you'll see that it's starting just that little bit higher. Again, it's coming in, just doing that final lick, that final clean up pass. Cool. Turn our router off again. Cool. So hopefully that gives everyone a little bit of an idea on how to go from Fusion and go into CAM and then going into CNC machining. The goal with this video was not to create a long-winded video. Again, I really want to create some really focused videos on those individual processes, or that individual how to cut something, or how to program something, or how to draw something within Fusion. But today was just going from Fusion going to CNC cutting, machining something. So as you can see, if I home the machine now, Z-axis is going to home first, and then we've got our 4 little bores, and hopefully this has been helpful for you guys. And if you guys have any questions, please fire away. You're correct, stupid Robot Fighting League. When squaring a machine, it's not at all hard to bring the gantry up to the very front of the machine. If the gantry is slightly off square, all you want to do is the side that is closest to the front plate, you allow that to hit first, and then you bring the other side up to that point. Now, another customer brought up the answer recently that another way you can do that is to turn it off once one side hits, and you can actually wind the lead screw yourself to hit the other side. But again, step motors generally, they don't, you can afford to lose a few steps with a step motor, providing you home the machine before you go and rerun the program. That's going to allow you to just level up that gantry. It makes it really simple to do that. You're not really doing any damage. The step motor drivers that we've got are fairly smart in how they operate. They actually do put out warnings every time you do lose steps, but again, you're not doing any mechanical or electrical damage, apart from the fact that it doesn't sound that great when you are leveling that up, but it's not doing any damage. So just something to remember. Cool. Where's the touch probe, Casper? Again, it's work in progress. The touch probes are coming along really nicely. I probably need another solid week to finish them off. I'm just having a few issues at the moment with figuring out how I'm going to anodize it and how I'm going to be able to machine it and then anodize it afterwards. Because obviously, when you anodize something, you lose continuity, because anodizing does corrode or the outside of that material. So basically, what we're having to do is anodize it and then go back in and CNC machine it. Now, I've had a few people ask me why bother anodizing them, because at the end of the day we want to be able to create a really premium feeling product. We don't just want to be able to, we don't just want to start creating them now, sell them all, and then do an anodized version later on, because then it's not really being fair to everyone. We really want that product to be perfect before we release it. There's been a lot of times in the past where customers have rushed us to release something when we're not really ready, or perhaps we've rushed ourselves because we've needed to make some sales. And at the moment we're in a position where we really want to get things right before we release anything else, and I really hope you guys can all understand that. Cool. Well, hopefully you guys all enjoyed this, and I'm not too sure if I'll be able to do one next Sunday as well. But apart from that, we hope to do these every Sunday, like I've said, and it's want to make it a really regular thing. So the next one, what I want to do is I really want to focus on CNCJS and CNC machining. So what I'll do is I'll have some pre-cammed models, and I'll just take those to the machine, and we'll talk a little bit about zeroing out and how that works, and some of the ways that you can do that without utilizing a probe. And then hopefully by that time the probe will be ready, and we can do some demonstrations with that probe at that time. So apart from that, Merry Christmas everyone, and I hope you all have a good break away, and yeah, we'll see everyone again in the new year and that. So cheers.